Okay, 2.3 curve sketching, cubic function. Okay, the general form of the cubic function, fx here equals to the ax cube plus bx square plus cx plus d. And before you sketch the graph of the cubic function, first here you find the stationary point of the cubic function. Yeah, so you find the stationary point of the cubic function using the first derivative. Okay, first you find the stationary point of the cubic function. So you find the first derivative of the function. F prime of x here equal to the 0. Yeah, so this stationary point exists when the first derivative here equal to 0. And b, you find the inflection point. Inflection point, you find the second derivative, and you let the second derivative here equal to 0, and find the inflection point. And c here, x-intercept and the y-intercept of the cubic function. X-intercept, y here equal to 0, and you find the value of x. And the y-intercept, x here equal to 0, you find the value of y. And last, you sketch the graph of the cubic function. Yeah. So shape of the cubic function, first here, first when the coefficient of the coefficient e greater than 0 or positive. Okay, so shape of the cubic function from the left here, graph concave downwards and concave up. Yeah, and second, if the value of a here less than 0 or a negative sign, so graph here from the left concave up, and here concave downwards. Yeah. Okay, question 11, sketch the graph of the cubic function y here equals to the x cube plus 3x squared minus 4. And question B, your homework. This one is your homework or exercise. Okay, step 1, before you sketch the graph of the cubic function. First step here, you find the stationary point of the cubic function. Y here equals to the x cube plus 3x squared minus 4. So the first derivative equals to the 3x squared plus 6x. Yeah. So you let the first derivative here equal to 0 and find the value of x. So you let the first derivative here equal to 0 to find the value of x. So this stationary point exists when the first derivative here equal to 0. And the first derivative 3x squared plus 6x equal to the 0. So you move out the 3x times x plus 2 and equal to 0. And find the value of x. The first value here equal to the 0. And x here equals to the negative 2. Yeah. Okay, and you find the value of x 0 and x here equals to the -2, and you substitute x equal to 0 into this cubic function, x cubed plus 3x squared minus 4. So the value of y here equals to the -4, and the coordinates of the stationary point at the 0, -4. This one the first point, and x here equals to the -2. You substitute into the function, and the y here equal to the 0, and the second point here at the -2, 0. Yeah. Okay, step 2, you find the relative maximum or the relative minimum point using the second derivative test. Yeah. Okay, so the first derivative here equals to the 3x squared plus 6x, and the second derivative equals to the 6x plus 6. Okay, so first point, x here equal to 0. Yeah, so x here equal to 0, you substitute into the second derivative, and the second derivative here equal to the 6, or value here greater than 0, and the sign of the second derivative here positive. Okay, so sign of the second derivative here positive, and the conclusion the relatives minimums exist, and the relatives minimum point at the 0, -4. Okay, first point. Okay, and the second point, when x here equals to the -2, okay, so you substitute into the second derivative, and y here equals to the -6, or here less than 0, and sign of the second derivative here negative. Okay, and the relatives maximum exists. Yeah, so relative maximum point here exists at the -2, 0. Yeah, so you find the stationary, you find the relative maximum or the relative minimum point here using the second derivative test, or you can use the first derivative test. Okay, so using the first derivative test, so you find you sketch the table. The first value, first row here, you put the value of x. Second here, first derivative dy over dx, and here the shape of tangent. Yeah, so using the first derivative, so shape of tangent here decrease, horizontal and increase. So here the minimum point. And the second value, x here equals to the -2, and the shape of tangent here from the left increase, horizontal line and decrease. So here the relative maximum point. Okay, so you can choose first derivative test or using the second derivative test to find the relative maximum or the relatives minimum point. Okay, step 3, find the inflection point. Okay, step 3, find the inflection point. Okay, so if you find the inflection point using the second derivative. Second derivative here equals to the 6x plus 6. Yeah. So you let the second derivative equal to the 0. So inflection point here exists when the second derivative here equal to 0. 6x plus 6 equal to 0, and the value of x here equals to the negative 1. Yeah. So you substitute negative 1 into the cubic function. X here equals to the negative 1. You substitute here. And the value of y here equals to the negative 2. And the inflection point at the negative 1, negative 2. Yeah. Okay, step 3, find the inflection point. And step 4. Okay, step 4, table of a concavity. So first row here, you put the intervals of the function. And the second row, the second derivative. And the third row here, concavity of a function. Yeah. So domain of the cubic function is all the real numbers, negative to the positive infinity. Okay, so domain of the cubic function is all the real numbers, negative to the positive infinity. And the inflection point here, value of x equals to the 1. Yeah. So from the left of the function, from the negative infinity. So first interval here, negative infinity 1. And the second intervals 1 to the positive infinity. Yeah. So the first row here, you put the first interval between negative infinity and 1. Okay, and the second column you put the second intervals 1 to the positive infinity. Yeah. Okay, and you pick the nearest value, negative infinity to 1. The nearest value of x here equal to 0 from the left. And here 1 to the positive infinity, the nearest value here x equals 2. So you substitute this value into the second derivative and determines the sign of the second derivative. Yeah. Okay, corrections. The first value here, the value of x here equals to the negative 1. Yeah, negative 1. So the first interval here, negative infinity, negative 1. And the second intervals, negative 1 to the positive infinity. Okay, betul. Yeah. So the first value, the nearest value for the first interval, you put here the value of x here equals to the negative 2 from the left. And negative 1 to the positive infinity, the nearest value x here equal to the 0. Okay, baru betul. Yeah. So you substitute this value into the second derivative and determines the sign of the second derivative. So the second row here, when x equals to the negative 2, the sign of the second derivative here equals to the negative. And the second interval, when x here equal to 0, the sign of the second derivative here equals to the positive sign. Yeah. And number 3, concavity of the function. So when the second derivative here negative, so graph here concave downward, CD. And the second interval, second derivative here positive, so graph here concave upward, CU. Yeah. So when you draw the graph of the cubic function, from the left here, graph here concave downwards. And then after x equals to the -1, graph here concave up. So you combine this one from the left here concave down, and here concave upwards. So this inflection point exists at the -1. Yeah. Okay, step 5, you find the intercept of the function. Okay, so you find the intercept of the function. First here you find the y-intercepts of the cubic function. Okay, so y-intercept of the cubic function when x here equal to the 0, so you find the value of y, and here you substitute 0 here into the cubic function, x cubed plus 3x squared minus 4, so y here equals to the -4, and y-intercept here at the 0, -4, yeah. And the x-intercept of the function, y here equal to 0, so 0 equals to the x cubed plus 3x squared minus 4, and you find the value of x here equals to the -20, first intercept, and the second intercept here at the 10, yeah. Okay, and step 6, you draw the graph of the cubic function. Okay, before you sketch the graph of the cubic function, first you label the intercept of the function. So the x-intercept here at the -20, 10 you label, and then the y-intercept of the function here at the 0, -4, and the inflection point at the -1, -2, yeah. And the shape of the cubic function, from the left here, graph concave downwards, and after -2, graph here concave up. Okay, so from the left, -infinity to the x equals to the -1, graph here concave downwards, Okay, so between negative infinity and negative 1, graph here concave downwards, and after negative 1 to the positive infinity, graph here concave up. Yeah, and this one you labels the intercept, x-intercept, y-intercepts, and you write down the function. Okay, so this function y here equals to the x cubed plus 3x squared minus 4. Okay, so this one, the intercept of the function, you label y x here equals to 1, y here equal to 0. Okay, so this one you label the x-intercept, and then y-intercept 0, negative 4, inflection point, negative 1, negative 2, and here the function, the cubic function y here equals to the x cubed plus 3x squared minus 4. Okay, settle. Okay, so here the method before you sketch the graph of the cubic function. Okay, step by step. Yeah. So first step here, you find the stationary point of the cubic function. You let the first derivative here equal to the 0. Yeah, and the stationary point here exists when the first derivative equal to 0. And the second step, step 2, using the first derivative or the second derivative, find the relative maximum or the relative minimum point. Okay. Step 3, you find the inflection point. You let the second derivative equal to the 0. And then step 4, table of concavity. Step 5, intercept, x-intercept, and then y-intercept of the cubic function. And last here, you sketch the graph of the cubic function. Okay.